We're going to delve into a detailed discussion of the Fama-MacBeth regression, which is a particularly unique and robust statistical methodology that allows us to effectively estimate the risk premium associated with various assets. In this specific example we'll be examining, we'll utilize beta as our independent or X variable representing systematic risk, and the subsequent or lead return will serve as our dependent or Y variable. For this, I'll be using, as I typically do, the Finance Research Gate website. My objective is to obtain the same frequency for both X and Y, so I'll be working with just one single frequency. I'm going to use monthly data for this because it's essential that we possess a sufficiently large number of time periods to ensure the robustness of our analysis. So, with that understood, I'll now proceed.
Let's select
2000. And for the purpose of our current analysis, we need to select the end year, which will be 2020. Once that's established, we will then apply this specific period, which covers a total of 20 years. Following these steps, we will then proceed to carefully choose the main explanatory variable. The Fama-MacBeth method can be applied in various different applications and scenarios. However, its most common and widely recognized application occurs within the field of empirical asset pricing. Specifically, this is when researchers aim to test the influence or impact of a particular financial factor, for example, the CAPM beta, upon the expected return of a stock. In other words, the core question we are addressing is, do firms with a greater exposure to market risk as measured by their market beta value actually earn a higher rate of return in the following period? To properly test this, I will choose the appropriate market period for market beta from the given list. And the Y variable will be the stock return. In this particular scenario, since our analysis involves monthly frequency data, the specific measure we're using is the stock's monthly return. Please just give it a little more time because when we're dealing with a monthly frequency, we naturally have a much larger data set, and consequently it might require a few additional seconds to fully load all of that information. So what I'm going to do is introduce a lag, and this is crucial because we absolutely must make sure we prevent any look-ahead bias. This essentially means that we're using data that's available to us right now, today, to predict or test an outcome that will only manifest in the subsequent time period. Therefore, to properly account for this, I will then allow the X variable to, and then I will proceed to incorporate it into the existing data set. And then prior to commencing our analysis with the Fama-MacBeth regression model, it is highly recommended and indeed quite prudent to thoroughly examine the descriptive statistics of our dataset. This careful preliminary review is essential to ascertain and confirm that we do not possess any unduly extreme or outlier observations within our data, which could potentially skew our results. Unfortunately, we have a situation here, so we are going to deal with that by using the Windsorization technique.
And we can find that specific option or feature located right here within this interface. Then enable it.
Following this, our next step involves applying a Windsorization technique to both our primary independent variable, X, and our dependent variable, Y. The purpose of this procedure is to effectively manage and minimize the impact of any extreme outliers that might otherwise unduly influence the accuracy and reliability of our regression estimates. Specifically, we will perform this Windsorization at a 1% level. Subsequently, we will then incorporate these newly Windsorized variables into our analysis. Alright, so from here, what we'll do is scroll down a little bit further on the screen until we get to the advanced regression section. This particular area is exactly where you'll find the Fama-MacBeth model. Alright, let's turn our attention to the Y variable. At this moment, we need to allocate a little bit of time to properly examine this specific component. Okay, that seems like a good approach. Now we should proceed to select the Windsorized version of our Y variable. It's absolutely crucial to remember and not to overlook that our Y variable fundamentally represents the monthly stock return data for our analysis. And for the primary regressor variable in our analysis, we have specifically employed the Windsorized lagged market beta. Once we have successfully selected our Y and X variables within the advanced regression interface, we will then be presented with a number of different options to consider. It's important to note that we do not need to complete or fill in steps 2 and 3, primarily because these specific stages are not directly relevant or applicable to the Fama-MacBeth methodology. So we'll navigate directly to the Fama-MacBeth section within the interface and then select it. And then once this is complete, we will finally have the results. So specifically, within the Fama-MacBeth methodology, what we're going to do is in each distinct period, we will run a cross-sectional regression where the dependent variable is the stock return and the independent variable is its market beta. This particular step constitutes the first stage. Moving on to the second phase of this process, we will then proceed to derive numerous estimations or alternatively coefficients. These are specifically designated as the price risk. More precisely, the price risk associated with the market beta. In this specific scenario, we don't have a single coefficient. Instead, we have a number of coefficients, specifically one for every period, more precisely for each month. So, we'll start our process from the year 2000, right from its very first month. And for every subsequent month, moving forward from that point, we'll be assigning a single distinct coefficient. Now, these coefficients might be positive in certain months, while in others, they could be negative. They could represent quite large values, or perhaps very small ones, and so forth. We can summarize all of these coefficients by performing a time inference, which is achieved by simply taking their average. Additionally, we are also able to estimate the standard deviation of these specific values, again, utilizing the time inference method that is applied to these very same coefficients.
And these are summarized in the table presented here.
So, on average, the inherent price risk associated with the market beta is actually quite small. It's a remarkably low figure, specifically coming in at 0.04. This implies that for every single unit of beta, we can anticipate being rewarded with a mere 0.04%, which is a return that is considerably less than 1% when we consider the average. And so, looking at our results, we can see that the effective sample size for the Fama MacBeth regression, which is a crucial metric, comes out to be 252 observations. At this point, a very natural question might arise in your minds. Why are we not simply using a more straightforward approach, such as a standard panel data analysis, or perhaps just a basic ordinary least squares or OLS regression? Within this particular situation, our approach involves gathering all individual observations and then combining them into one overarching single estimate. However, by taking this specific action, we will inevitably lose a significant amount of truly important and valuable information. For example, we're assuming a single unchanging price of risk in our model, when in reality, the actual price of risk might well be dynamic and change over time. Additionally, another important consideration is that the errors we observe might not be independent from one firm to another. Therefore, it might prove to be a prudent approach to conduct those estimations on a monthly basis, specifically to accommodate for the potential error correlation observed among various firms. And the third crucial reason for its effectiveness is the robust way it allows us to handle and analyze time clustering. This implies that within particular time frames, we can identify and detect a notably significant price of risk that might otherwise be overlooked. Consequently, to gain deeper insights into these findings, you are welcome to access and download the comprehensive table. Alternatively, you'll find it presented right here. Additionally, there's an option for you to download a comprehensive table, which includes the associated standard error values. Furthermore, you can view the corresponding visual chart directly on this interface. This allows you to clearly see the coefficient, or more specifically, the price risk for every single period analyzed. And naturally, all of this valuable data is available for you to download simply by saving the file. So, that's everything regarding Fama MacBeth. I truly appreciate you listening.